August 29th, 2025. An ordinary night at a Hawaiian observatory, until astronomers spotted something impossible, a 62-foot object shadowing Earth's path like a ghost. For 60 years, this hidden quasi-moon, the smallest ever discovered, has been circling our world from millions of miles away, undetected by NASA and every survey in between. Only 7 of these secret companions are known to science. So how did an object the size of a school bus orbit with us for generations and go unnoticed? And if Earth can miss its own hidden moon, what else is hiding in plain sight? The answer begins with a single, almost overlooked signal. Night falls over Haleakala, and the Pan-STARRS telescope begins its methodical scan. On August 2nd, 2025, a faint smudge, barely a whisper against the starfield, registers in the data. This is not the flash of a meteor or the streak of a passing satellite. The object is magnitude 26. For perspective, that's 10 million times dimmer than the faintest star you can see with your eyes. Most telescopes wouldn't even register it, yet Pan-STARRS, built for hunting the darkest, fastest threats, picks up the anomaly. In the control room, the night shift team stares at the raw frames. The object holds steady through several exposures. No match in any asteroid or satellite catalogue. The system's algorithms, tuned to filter out noise and known objects, flag it for further review. For a moment, there's doubt. Could it be a stray artifact? A glitch? But the signal repeats, frame after frame, always in the right place, always moving just a bit in sync with Earth's path. Standard procedure calls for cross-checking with the minor planet center. Nothing. No known asteroid, no comet, no artificial object. The team reruns the detection pipeline, adjusting for every variable. Atmospheric distortion, cosmic rays, even the faintest hint of moonlight. Still, the object persists. By the end of the shift, curiosity turns to urgency. The team logs the detection, tags the coordinates, and schedules follow-up observations. The data is too clean, too consistent for a fluke. In the world of sky surveys, most discoveries are made by software, but this one draws human eyes. Seasoned astronomers leaning in, recalibrating their instincts. A 62-foot wide object, as long as a school bus, hiding in plain sight at distances up to 37 million miles. The evidence is undeniable. This is something new, and it's been right beside us for decades. Inside the Pan-STARRS control room, the discovery triggers a chain reaction. The team pivots from routine survey work to a full-throttle verification sprint. Every available astronomer is pulled into the hunt. The raw coordinates are fed into JPL Horizons, NASA's gold standard for orbital prediction. Within hours, the system spits out a preliminary orbit, nearly identical to Earth's, looping around the Sun in lockstep. Not a random asteroid, not a wandering rock, something that's been shadowing our planet for decades. But science demands more than a good fit. Analysts run Monte Carlo simulations, feeding in every scrap of data, brightness, position, motion. Each run returns the same answer. The object's path hugs Earth's, never straying farther than 37 million miles, sometimes coming within just 2.8 million. The odds of a fluke drop with every calculation. Still, nobody wants to be the person who cried hidden moon over a software glitch. Skeptics on the team dig deeper. They cross-check for satellites, space junk, even echoes from earlier Pan-STARRS runs. Nothing matches. The magnitude 26. Brightness is so faint it would escape most telescopes and fool most algorithms. But here, the signal persists. Veteran astronomers, used to chasing false alarms, find themselves recalculating orbital elements by hand, just to be sure. Every result points to the same conclusion. This object is real, and its orbit is no accident. By sunrise, a consensus forms. The data is airtight. The object, barely the length of a school bus, has been circling the Sun alongside Earth for at least 60 years. Internal chat threads light up with cautious excitement. Before anyone can alert the world, the team triple-checks every variable, reruns every simulation, and drafts a formal alert for peer review. The night ends not with celebration, but with a waiting game. Now the search for missed sightings in old archives begins. Every new discovery in the sky comes with a question. Has anyone seen it before? As soon as Pan-STARRS confirmed the object's orbit, researchers turned detective. The hunt moved from live telescopes to the digital vaults. Decades of images, stored by surveys like Catalina, Linear, and the historic Palomar plates. Each archive is a time capsule, packed with billions of stars, galaxies, and the faint trails of objects that almost slipped by. But finding a school bus-sized rock 10 million times fainter than the dimmest star you can see is no simple task. Automated search software is the first line of attack. These programs are built to pick out fast movers, the classic asteroids and comets, slow, faint objects that stick close to Earth's path. Most algorithms throw those out as noise or tag them as satellites. In the logs, these outliers earn comments like artifact or possible satellite, and usually that's the end of the story. Not this time. With a fresh set of coordinates and a predicted path, teams rewound the clock. They pulled frames from Catalina's 2014 run, combed Linear's nightly stacks, and even digitized old Palomar plates from the 1960s. Each image was run through new filters, tuned to catch the subtle motion of an object hiding in Earth's shadow. The process is painstaking, one frame at a time, each pixel scrutinized for a faint, moving dot. Despite the effort, no clear image of the object surfaced from before 2025. The absence itself became the clue. It wasn't for lack of trying or lack of technology. The object's faintness, its slow crawl across crowded star fields, and the quirks of survey software conspired to keep it hidden. Billions spent on telescopes, thousands of nights spent scanning the sky, and still a cosmic neighbor slipped through the cracks. The search for lost frames continues, not just for this quasi-moon, but for whatever else might be hiding in the archives. On August 30th, 2025, a single email hit the Minor Planet mailing list. Adrian Coffin, a science journalist with a knack for spotting overlooked details, flagged the Pan-STARRS object as something extraordinary, a quasi-moon, not just another asteroid. For most astronomers, it was the first time they had heard of the find. But behind the scenes, the real shock was not just the discovery. It was the realization that the object had slipped past every automated detection system for decades. The problem started with the algorithms themselves. Most sky survey software is built to find threats, fast, bright objects that might hit Earth. Anything that moves too slowly or matches Earth's orbital path too closely gets filtered out as either a satellite or an image artifact. The logic is simple. Real asteroids do not usually move like that, so the code throws them away, night after night, year after year. This is not just a technical quirk, it is a culture, baked into how astronomers hunt for danger in the sky. The software is tuned for speed, not subtlety. If an object creeps across the stars at the same pace as Earth, it is almost invisible to the filters. Even a 62-foot wide rock, big enough to flatten a city block, gets lost in the noise. Billions of data points, and the one that matters most is tossed out by default. Coffinet's public alert forced a rethink. Within days, survey teams began rewriting their code. New parameters were added to flag slow movers, even if they looked suspiciously like artifacts. Engineers debated how many false positives they could tolerate, weighing the risk of missing the next hidden companion. The mailing list alert was not just a footnote, it was a wake-up call. For the first time, the astronomical community had to admit that their best tools had a blind spot. The discovery did not just reveal a new quasi-moon, it exposed the limits of the entire detection system. A 62-foot wide rock. That's the length of a classic yellow school bus, nose to tail, parked right beside the curb. Not a cosmic mountain, not a city-sized moon, but something you could almost imagine rolling through a neighborhood. Yet this school bus-sized object has been tracing the same path as Earth for decades, slipping between 2.8 million and 37 million miles away. Sometimes it's closer than Mars ever gets, sometimes it drifts off to the far edge of our planet's gravitational reach. For scale, 62 feet is about as long as a semi-truck with its trailer. Stack 2 NBA basketball courts end to end, and you're just about there. In the vastness of space, it's a pebble. But here's the catch. Out of all the objects that share Earth's orbit, only 7 have ever been confirmed as quasi-moons. 7. That's fewer than the number of continents, or the number of people in a crowded elevator. Most planets don't have any. Mars, none. Venus, 0. Earth's club is exclusive. So exclusive that every new member is a headline. And this one is the smallest of all. Astronomers call it 2025 PN7, but it could just as easily be called the cosmic wallflower, always nearby, never noticed. For more than half a century, it's kept pace with us, orbiting the Sun in lockstep, never straying too far, never getting close enough to light up the night. Finding something so small, so faint, hiding in the open for so long is like discovering a secret room in your own house. It's a reminder, even in the era of giant telescopes and sky-mapping satellites, the universe still has surprises tucked right under our noses. Earth's new companion isn't a moon in the way most people imagine. It doesn't circle our planet like the familiar lunar disk. Instead, it orbits the Sun, tracing a path that closely matches Earth's own, locked in a delicate gravitational dance called co-orbital resonance. Imagine 2 runners on a track. One is Earth, the other is this tiny asteroid. They stay in step, sometimes pulling ahead, sometimes falling behind, but always looping around the Sun together. Their paths never cross, but they remain tethered by timing and distance. Carlos de la Fuente Marcos, an expert on these cosmic tagalongs, puts it plainly. 2025 PN7 is not a true satellite. It's a quasi-moon, an object caught in a near-perfect rhythm with Earth. The distinction matters. While our moon is bound tightly, always circling Earth, a quasi-moon, like 2025 PN7, is freewheeling, held in place only by the subtle push and pull of gravity. It never completes a full orbit around Earth itself. Instead, it weaves a looping pattern, sometimes leading, sometimes trailing, but always staying close enough to be considered a companion. This co-orbital resonance is rare. Only 7 objects like this have ever been confirmed. Most planets don't have any. The path is stable for decades, but it's not forever. Over time, tiny nudges from the Sun, the planets, and even the faintest pressure from sunlight can break the spell. For now though, 2025 PN7 remains in lockstep, a cosmic partner, gliding beside us, almost invisible, yet never truly gone. Every cosmic partnership has an expiration date. For 2025 PN7, the clock is already ticking. Orbital simulations run by astronomers show this quasi-moon will keep shadowing Earth until about 2085. After that, the gravitational choreography falls apart. Tiny nudges, sunlight, the pull of other planets, even the faint pressure of solar wind add up over decades. By the time today's elementary school students reach retirement, this 62-foot wanderer will slip away, breaking free from Earth's side. Right now, its distance swings wildly, sometimes just 2.8 million miles away, 12 times farther than the Moon, sometimes drifting out to 37 million miles, nearly halfway to Mars at its closest. But that range won't last forever. As 2085 approaches, models predict the object's path will drift, its orbit stretching and twisting until it finally escapes this rare resonance. The departure won't be sudden, a slow fade, not a dramatic exit, but when it's gone, it won't return in our lifetimes. This countdown isn't just a scientific curiosity, it's a reminder. The window to study, visit, or even just track this cosmic neighbour is closing. For the first time, astronomers can watch the end of a quasi-moon's era in real time. The next 60 years are all we get. After that, 2025 PN7 will become just another anonymous rock, lost in the glare of the Sun. Its secret partnership with Earth finished for good. 60 years left on the clock. That's the window scientists, and anyone with a curious streak, have to get up close with Earth's most elusive companion. But this isn't just a job for NASA or university labs. The story of 2025 PN7 is already spilling out of observatories and into backyards, classrooms, and online forums. Amateur astronomers across the country are racing to spot the faint dot themselves, stacking images, tweaking software, and sharing tips late into the night. Some manage to snag a pixel-bright glimpse using telescopes barely bigger than a mailbox. Others join the hunt by running code that sifts through public sky survey data, hoping to catch what the pros missed. With a school bus-sized target and a countdown ticking, ideas are flying. University teams sketch out CubeSat missions, tiny, low-cost spacecraft that could hitch a ride on rockets already heading for deep space. Imagine a suitcase-sized probe snapping close-up images of a rock that's shadowed Earth since the Beatles broke up. Private donors and student groups are pitching in too, dreaming up solar sail flybys or swarm missions that could tag along as 2025 PN7 loops around the Sun. Funding is a scramble, but the prize is clear: a front-row seat to a cosmic event that won't repeat for generations. For anyone with a telescope, a knack for coding, or just a restless sense of wonder, the door is wide open. There are 60 years left to chase a hidden neighbour, to turn curiosity into discovery, and maybe, just maybe, to find the next secret circling overhead. What else is out there, waiting for someone to notice? On August 29, 25, Pan stars in Hawaii detected 25 PN7, a 62-foot wide quasi-moon that has followed Earth for at least 60 years. Archival images from 2014 and evidence suggesting a presence since the 1960s confirm how easily such objects can escape even modern surveys. With only 7 known quasi-moons, this discovery is both rare and significant. Yet questions remain. How many more objects like this have slipped through our detection systems? What else is hiding in the millions of miles around our planet? The fact that 225 PN7 will remain in Earth's neighbourhood until 2085 provides a unique time-limited opportunity for study. This case exposes the blind spots in our technology and the need for constant vigilance. In the end, the story of Earth's hidden companion is a reminder. Sometimes, even in our own cosmic backyard, there is more to discover.